All right, hello everybody. Thanks for joining us at Mimi today. We're still waiting for a few of our key participants today, in particular the presenters, to join us, and then we'll get started in a few minutes. But I think while we wait, we can probably deal with some of the admin stuff and the chair deck. So let's plow on. So first off, as usual, we need everybody to note well and make sure that you're aware of the IETF's policies on intellectual property as well as the code of conduct. This also reminds me that it being October, I believe it's currently Cybersecurity Awareness Month. So if you were not already aware of cybersecurity, you are now aware of cybersecurity. Okay, as usual, we need a note taker. I think for the sake of expediency, I'll just take care of that today. And finally, for the agenda, so we're going to start with Rowan, once he gets here, talking us through what's new on room policy. Then Conrad has an update on Mimi, the scheme for metadata minimization in the Mimi protocol. And then, time allowing, we'll come back around to some of Rowan's ideas on message franking. And I suppose last programming note for today is that I believe we're only doing 1 hour out of the scheduled 2 because something like 3 or 4 of our participants today have some other commitment they have to get to at the end of the hour. So, sorry, I'm just futzing with the note-taking app. But with that, I think we can get started. Rowan, I'm going to throw up your slides.
Thank you.
Here we go.
Okay. Next slide, please. Okay, so I presented basically most of these slides before, but the idea behind having this role-based access control was something that I brought up, but didn't really have a great list of capabilities for. And then we're going to have a in the next slide, I'll show some of the capabilities that I came up with based on feedback and analysis. So we go to the next slide, please. Okay, so here we have, I tried to come up with different categories of capabilities, but the idea would be that if I have if I assign a role like an ordinary user or an admin or a moderator, that I can grant certain, the creator of the room or the admin, if they have that permission, can grant certain capabilities, and then authorization of certain activities would happen automatically based on those, on the holder having that role in the participation list and trying to take certain actions. So for example, under membership capabilities, we've got can add participant, can remove participant, can add own client, can remove self, can add self, can create a join link, can use a join link. So those are all related intimately to whether you're whether you can change the membership by adding and removing a user in some way, or a client that is affiliated with one of those users. All right. Then I had a section on moderation capabilities. So I had being able to ban or unban, kick, revoke voice, grant voice. In the Jabber world, revoke voice, grant voice, that means that you can type, or like if I revoke voice, it means that you can receive messages, but you can't send messages. And likewise, grant voice means that you can send messages, but it's like sometimes in very large rooms, you might have a room where it's primarily for announcements, and you have to take some particular action to get permission to be a speaker, and then you have voice, and then you can send messages. Yeah, there's a couple things about knocking, which that is very much like notional because we haven't really decided if we're going to have Knox or not, but if we wanted to have Knox, that would be a way to have that capability. Then moving over to message capabilities. So we have here, can send a message, can receive a message. Those are things which the hub has an ability to enforce. And to a certain extent, this can report abuse capability could be enforced by the hub. The rest of the capabilities that are listed here, if we want something like that, reacting to a message, editing a reaction, deleting a reaction, editing your own message, starting a topic. These are all things which, because the content is encrypted, it would need to be enforced by other members of the MLS group, other participants in the room. Okay, I'm just gonna very, very lightly highlight under asset capabilities. I've got the ability to upload images, upload and download images, videos, attachments, and to send links and link previews and follow links. So these, there seem to be several different variations on these kind of features across many different messaging platforms. I have not exhaustively looked, and so this would be an area particularly where it would be nice to see what other people have seen in the industry and what they think is useful. Okay. Finally, I'm just going to point out that at some point we have in our charter that we might end up doing real-time media, and so being able to start or join or end a call, sending audio, sending video, receiving audio, receiving video, screen sharing, those are all things that are very popular kind of policy knobs when that is a feature which is available in the system. So I'm going to stop here for a minute. Oh, hi, Richard.
Hi, good morning. So, yeah, thanks for the exhaustive list here, Rowan. It's very thorough. I might suggest that the key thing to get at this point is the framework. We have a fairly basic protocol at this point. So, let's capture the framework and the things that relate to things we have right now. And then as we add functionality, we can add the policy knobs that go along with.
Yeah, I think what I was aiming for here was sort of an existence proof that things that can be done on other systems are possible and would fit nicely into this framework. But we could start by defining, a relative, maybe a third or half of the capabilities that are listed here. Okay, and I've neglected to mention, I'll go ahead and send it in the chat, but I did update the editor's copy of, excuse me, of this draft here. So I'll send that in shortly so that people who want to look at this in draft form have access to it. Whoops, don't want that. Sorry, wrong window. How about that link? That's better. Okay. If there are no more sort of questions or comments on this slide, I'm just going to go to the next slide, and we can kind of quickly go through the rest, and then I'll yield. Raphael.
Thanks, Richard was first.
Okay.
I'll go ahead. So I'm wondering how we can meaningfully distinguish between videos, images, and other files when we use end-to-end encryption. So that part is not entirely clear to me. How are we going to solve that one? And I was wondering if you have any ideas about that.
Yeah, I mean, I think this is like the like the bulk of the message capabilities, the items listed there, this is also something which is going to have to be enforced by clients.
Okay.
A
And
well-behaved
one
client,
last,
yeah, go ahead.
okay. One last question. What's the difference between a direct message and a target message?
So I think in many messaging systems, sending a DM means that I'm sending to exactly one individual, whereas a targeted message could be for any subset of users that are in the group.
Okay. Thanks for clarifying.
Okay. Tim, could you go to the next slide, please? All right. So I did prepare a couple of there are 3 examples here in the slides. The idea here. So one of the things that came up when I was doing, kind of looking at the ability of, I did not list a specific attribute for promoting or modifying roles, but that is also that is something that needs to be defined. And so this is a sort of a capability that needs parameters. So I wanted to bring that up separately. But in many schemes, you have this sort of implied concept of like there's an order to roles. I don't think that it's necessary for us to maintain in the protocol an order to roles. We can just say these attributes, even though the way that, for example, this example is given, an ordinary user can do everything a guest can do, plus this could be, that could be expressed in the user interface, but in the actual nuts and bolts of the protocol, the list of capabilities would just be, for an ordinary user, would just be the whole list of capabilities of an ordinary user, which happens to also include 3 of the capabilities that are in a guest. Likewise, in a group admin, that would include all of the capabilities that an ordinary user and a guest can do. Go ahead, Tim.
Thanks. So, okay, so you're illustrating here policies that are defined in terms of other policies, or rather in terms of other groups. So, and presumably maybe this can happen, they could also refer to users. But in either case, what's the sort of canonical representation of a group that would appear in a policy definition?
So what we would say is there would be 1, 2, 3, 4, 5 roles defined for this particular room: band, guest, ordinary, group, admin, and super admin. And then for each of those, there would be there would be 5 roles, and then in an array, and then one of the parameters would be, what is the human readable name of this role. So one of them would be band, guest. You could call it whatever you want, but for the sake of this, like, I'm giving names that sort of make sense. And then there would be a list of capabilities for each of these roles.
So then the roles are identified by a string that is unique per room.
Correct.
And chosen by the room's admin, or like whatever entity is sort of bootstrapping the policies for the room.
Yeah, like you can imagine that this would be likely to be very constrained between the client and the hub, that they would, the hub would may already have like a menu of these that could be slightly modified, but mostly there would be a bunch of defaults for this kind of thing.
Okay, makes sense. Thanks.
One thing that I had yet to mention here are the concept of role constraints. So you can end up in a situation where if let's say you have admins and only admins can add and remove people, if the last admin leaves a group, you're screwed. So having a role constraint, I created minimum and optional maximum constraints for each role when I represented this. So we would have, a minimum number of group admins is 1. And for everything else, it's just, yeah, you don't have a maximum number of anything, and there's no minimum number of there's no minimum number of participants in any of the other roles in this example. All right. So just to compare and contrast the 3 examples that I gave. So in the strict administrator approach, only the group admin can add and remove users. If we go to the next slide, this might be in a cooperative room, which might be, say, to friends and family. Every user can add or remove, or maybe just add, but you need a group admin in order to banish someone, for example. And maybe in this case, like every user can change the subject, the room name, things of that nature, metadata associated with the room. Next slide. And finally, in a moderated room, I came up with different names for different roles. So here we have an attendee, a speaker, is allowed to send messages, that can send attachments and images and so forth, and a moderator who does all of the banning, adding, removing, answering knocks, and so forth. Go ahead, Tim.
This is a bit out there, but is it possible to have policies that say require 2 people from some group to approve an operation? Like, say, if you want dual control over allowing some new user to enter a very sensitive room?
I had not thought of that requirement. I don't have a way off the top of my head to do that with this proposal.
That makes sense. And like that sort of dual control thing can be tricky because it's stateful if, say, the approvals for multiple actors come in like at different times. So maybe we'd have to think about whether anybody wants this before bothering to solve it. Thanks.
Okay. All right. So that's all I have on this. But as I said, I've been little by little, I've been putting this into draft Mimi room policy. And I think we can, kind of refine both the definition of the framework, the definition of the capabilities that we think are necessary for a sort of basic interoperable Mimi implementation. Yeah, look for. I'll be asking for some agenda time to discuss a more polished version of this in Dublin.
So I just want to repeat a question from the chat here. Timo asks, is can receive message enforced by the hub and followers, or do clients need to remove the user from the MLS state?
So there's no need to remove the user from the MLS state for a can receive message. So that would be enforced by both the hub and the followers. Presumably the hub would not fan out a message, but if a message did arrive, a well-behaving client shouldn't display a message if it received it and it knows that it's in that state. But that's also like kind of a witness of why question it's easy to do. It's easy to ignore in this state, and not everybody has this can receive message concept, and so we may decide that we don't want this capability at all anyway. The much more important one is the send. Yeah, so Britta asked if the roles are committed cryptographically, and so because the roles are in the participation list. The participation list is covered in, you would send an app sync to add, Alice would send an app sync to add Bob to the room and would add Bob as an ordinary user or as a speaker or a moderator or an ordinary user. And so in that way, it's in the group context and it's bound cryptographically to the group. Okay, I'll hand over, if no further questions, I'll hand over to Conrad.
All right, hello everyone. So similar to Rohan, we talked about this pseudonymity stuff in a few previous meetings, and we previously pushed an update to our Mimimi document, although we haven't actually pushed a new version yet, which we should do in the next couple of days. And yeah, I wanted to talk a bit about the details that we put in there, mostly about the how the pseudonymity works in the groups themselves. But yeah, let's get into it. Next slide, please. Okay, so this part where Alice connects to Bob. Sorry, let's start again. So for the notion of pseudonymity, as I mentioned in previous meetings, we need some sort of connection between two folks. And as part of this connection establishment process, the two parties involved must exchange a key called connection key. So in this case, Alice has a connection key and Bob has a connection key. If they establish a connection, they share. Alice gets Bob's connection key, and Bob learns Alice's connection key. In the document, we have a kind of proposal of what connection establishment could look like, but this, I think, also touches on other places in Mimi where we might want to have something like a connection or something similar to that, where, for example, you give someone permission to fetch key packages or something. And so how that plays into these other features, we'd have to see. But yeah, for now, in the document, we have a kind of one way of doing that. Richard.
And sorry if I missed something here. Is the idea they exchange connection keys out of band with respect to Mimi?
Good question. I mean, if they're from different providers, it probably should be Mimi, because there must be some sort of agreed upon standard, I guess. So yeah, we probably should have a way of doing that.
Okay, thanks.
Okay, so for the sake of the rest of this presentation, I'm just going to assume that people that are connected, they have a connection key, and the details of how they get connected. Again, for a proposal, you can look into the document, but maybe this is for another meeting. For now, I want to focus on how the pseudonymity works within individual groups. Next slide, please. And so before we get into a group, let's kind of start at the beginning of the whole kind of pseudonymity or pseudonym lifecycle. And that starts when Alice wants to publish a key package. And so she starts by creating pseudonymous, sorry about the typo in the pseudonymous credential TBS, which contains the pseudonym of her client, pseudonym of the user, or of Alice, and then signature public key. And the signature public key is the key that MLS is going to use for message authentication. And then in addition to this pseudonymous credential TBS, Alice also creates a identity link TBE, which contains a signature over the pseudonymous credential TBS by the signature key that's in Alice's actual credential that contains her real identity. Again, I don't think we have a notion of what this looks like yet, but it should be able to sign things. So this is what's happening here. And then in the next slides, Alice kind of composes this to an actual pseudonymous credential by creating an identity link key, which she derives from her own connection key that she shared with all of the folks she has a connection with, for example, Bob and the examples that will follow. Sorry, Richard, are you still in queue? See queue?
No.
Okay. So right, so Alice derives this identity link key, and this identity link key is unique for each key package that she publishes. And each key package, and I should have mentioned it on the previous slide, each key package has its own pseudonymous credential, with its own unique client pseudonym. The user pseudonym is shared among like a batch of key packages. Again, it's a mechanic that's required, but that we might want to talk about. And I don't think it's super relevant to the rest of the mechanics here, so I'll leave it at that. So the pseudonymous credential TBS is going to be unique for each key package, and thus the identity link key is also going to be unique. This becomes important later on when that link is shared in the context of a group. And so Alice derives the identity link key, and then she uses that to encrypt the identity link TBE that we saw on the last slide that contained the signature over the pseudonymous credential TBS and Alice's actual credential. And then Alice composes the pseudonymous credential TBS and the resulting ciphertext to an actual pseudonymous credential. And this is the credential that's going to live in the keys of MLS groups that underpin Mimi rooms. Alyssa.
So Alice has one pseudonymous credential per client?
Per key package.
Okay.
This is to make sure that her pseudonym is not trackable across groups.
So that sounds like one per device per group.
Yes.
Assuming key packages are one-time use.
Yes.
Potentially some cross-group leakage if key packages are reused across groups.
Right. Last resort key packages will compromise this a bit.
Okay. Thank you.
Okay. Yeah. Thanks for the question. Good question. Good point. So Alice has a pseudonymous credential, and now let's take a look at what this looks like in a group or in the individual group flows that we have. Next slide, please. So before we look at the join and the add flow, let's look at group creation. So when Alice, for example, creates a group, she samples an additional key. This is freshly sampled, it's not derived from anything, called an identity link wrapper key. The key is static, for now at least. Later we want to replace this with something a bit more involved. We talked about briefly before called tree wrap, but that's something that we need to fully specify. But that's going to give us nice PCS and forward secrecy guarantees. But for now, for the sake of this example, let's assume, and for simplicity, let's assume the key is static. So Alice samples this fresh key, and she encrypts her own identity link key, or at least the identity link key belonging to the key package, which she uses to bootstrap this group. And she encrypts the identity link key under the identity link wrapper key. And then she takes the ciphertext and includes it in the group state. Includes the ciphertext as part of the group's AppSync state. So I've mentioned AppSync here because it seems like that might be something that we're going to use in the context of Mimi, but it could also be some other mechanism that ensures that this becomes part of the group state and is stored on the hub as part of the group context. But AppSync seems to be the natural way of doing things, and it's quite an elegant way of doing things here with the pseudonyms. Okay, so Alice has created the group. The group state is on the hub, and the group state includes Alice's identity link key encrypted under the identity link wrapper key. The identity link wrapper key is not uploaded to the hub. The hub doesn't know it, and so the hub cannot decrypt the ciphertext. But the identity link wrapper key will appear in the add and join flow that we're going to look at next. Next slide, please. Thanks. So yeah, let's look at the add flow. The assumption here is that Alice is connected to Bob, and so this is a requirement. If a user wants to add another user, then they need to be connected. And so Alice first gets a key package for Bob, and then she creates a Mimi message or a Mimi add message to add Bob to the group. And in that message, which contains the MLS commit, which in turn adds Bob to the group in a leaf. She also includes an AppSync proposal that contains the ciphertext and contains Bob's identity link key. Again, this is the identity link key that corresponds to the specific key package that's representing Bob in the group when Alice adds him. And the AppSync proposal adds the identity link key encrypted under the same identity link wrapper key and adds this to the group state. Now Alice, as part of this add flow, Alice sends a welcome message to Bob. And in that welcome message, Alice includes a group info extension that includes this identity link wrapper key. And recall that the group info is encrypted within the welcome to Bob. So the hub, neither the hub nor any of the other followers can actually see this identity link wrapper key. On the receiving end, Bob receives the welcome, and then Bob can either decrypt the identity link key of Alice, which is part of the group state, or because they're connected, Bob can also just derive it from Alice's connection key based on Alice's pseudonymous credential. In this case, both things are possible because they're connected, but as we'll see in the next flow and the next example, again, this works also when someone is not connected to another group member. So yeah, Bob decrypts the identity link ciphertext in Alice's pseudonymous credential, which reveals both Alice's real credential and the signature over the rest of the pseudonymous credential. So Bob can actually verify this kind of chain that connects Alice's true credential to the pseudonymous credential that Alice uses in the context of this group. Okay, next slide, please. Okay, so another add flow, but this time Bob adds Charlie, and Charlie is not connected. Is connected with Bob because again, people need to be connected if they want to add each other to groups. So Charlie is connected with Bob, but not necessarily with Alice. And so this should work also. Of course, people should be able to be in a group together with folks that they're not connected with. So essentially a very similar flow. Bob fetches a key package for Charlie and derives the matching identity link key. Again, because Bob and Charlie are connected, Bob has Charlie's connection key and can derive the identity link key for this particular key package. Bob can check that the pseudonymous credential in the key package is actually Charlie's, just to double check. And then Bob encrypts Charlie's identity link key under the group's identity link wrapper key. Yeah, Ron.
Alice is checking this in Charlie's leaf node, or Alice is actually inspecting a real key package at this point.
We'll get to Alice. I'm still in the explaining how Bob. I mean, it's essentially the same as in the last slide, but Bob is essentially preparing all the information that Alice then needs to verify Charlie. But as soon as Alice gets this add message, which includes the AppSync proposal with the encrypted identity link key, Alice then decrypts the identity link key and can verify the pseudonymous credential that's in the key package. Does that answer your question?
I think so. Yeah, I think I'm following. Please carry on.
Okay, thanks. Richard, you want to chime in?
I was just going to try and re-summarize, but I'll wait for you to finish and then I'll try and read it back.
I was finished with the slide, so feel free to read it back if you want to.
Okay, so it seems like Bob and Charlie have a relationship under which Charlie's identity is revealed to Bob, and then Bob basically re-encrypts that information to the group in this AppSync so that Alice can interpret the ad using the extra key material. So whoever does the ad kind of imports the encrypted identity information into the group. Is that kind of the right intuition to have?
Yeah. Yep. Again, it's mostly just key wrapping and these encrypted credentials and signatures in the credentials. So it's no black magic, but just wanted to show that all these flows still kind of work. And so let's finish up with the last flow here for now, with the join flow. Next slide, please. Thank you. And so this is Dave now also joins the group. Oh, sorry, I forgot Charlie in this picture. So my apologies. So Dave joins the group with Alice and Bob. And Dave doesn't necessarily have to have a connection with either Charlie or Bob. So Dave only needs to acquire the group's identity link wrapper key, and this is assumed to happen out of band. So for example, if we want to support something like a join link, then the identity link wrapper key could be encoded in the link, or Dave could, I don't know, obtain that link from somewhere else. If we talk about the join flow for clients of existing members, then the new client could get the identity link wrapper key from an existing client. So, but yeah, this is a limitation that Dave or whoever joins externally needs to somehow obtain the identity link wrapper key, or if they don't, then they cannot identify the other group members and only sees the pseudonyms. So yeah, continuing, Dave creates an external commit, and in this external commit, Dave also includes an AppSync proposal similar to the add proposal, except now that he wraps his own identity link key in the group's identity link wrapper key, and make sure that this goes into the AppSync state. And this is kind of a catch here a little bit. This requires AppSync proposals to be legal and external commits, which they currently aren't. So if we have an AppSync extension, it would be nice to make it allow this in external commits. So if that works, we might have to figure out in the MLS group, but for now, at least, this is a requirement. But we could also, it's also conceivable to have the identity link, the encrypted identity link key in the AAD and then edit later or something along those lines. So yeah, just something to note here. Yeah, and the recipients can essentially follow the same pattern as with the last flows. They decrypt Dave's identity link key, verify the pseudonymous credential, and then decide to accept the external commit or not. And I think that was pretty much it. Next slide, please. Is there another slide? No. Okay. So yeah, this is a summary. So just to summarize a bit, this kind of technique exposes the pseudonyms to the hub, but not the real identities. The identities are hidden in an encrypted kind of section in the credential, and the keys for de-pseudonymization are disclosed to other group members using this key wrapping mechanism, but not the hub and not other followers. And this requires the notion of connection. What that looks like, again, there's a proposal that hides metadata, or that makes an effort to hide metadata, is in our document. How much of this goes into the actual document depends on what other kind of things we might want that use a connection or a notion of connection. Right. We require this out-of-band distribution of key material for external joins. And finally, just a note on this, I think we discussed this last time, this kind of user-level pseudonymity or feature-level pseudonymity, where pseudonymity can be used as a feature so that people are actually truly pseudonymous and identities do not get revealed or only get revealed partially. You can do that by just not including an identity link key or potentially not including an identity link ciphertext in the first place in your pseudonymous credential. But yeah, that we'd have to work out if we know what these features should look like. For now, this is just kind of trying to enable all the kind of features that we want to have, even without, in the base maybe case. Tim.
Thank you. So I'm concerned about the connection keys, which, as you say, have to be distributed out of band amongst, I guess not everyone. Just it seems like it depends upon the exact join flow being used, whether or not any two participants have to have exchanged connection keys. So is my intuition correct that we could not rely on the hubs to distribute these connection keys? Because if the hubs can do that, then they can defeat the pseudonymity, right? And the point of all this is to conceal. Okay, so yeah, that's kind of the thing that concerns me, because then if the hubs can't do it, then that means, my intuition is that there's going to have to be some PKI that distributes this, and that seems tough. Like, is a PKI roughly how you envision the connection keys being distributed, or do you have some other scheme in mind?
Right. So the scheme we had in mind was a kind of two-flow scheme that we call the connection establishment. So if Alice and Bob establish a connection, they do that explicitly, and I don't know, Alice discovers Bob, and Bob, like, I'm just sketching the scheme that we have in the document. So Alice discovers Bob, and in the process of discovery gets a public key that is associated with Bob. Then Alice can use that public key to send Bob a connection request, an encrypted connection request, which already contains Alice's encrypted connection key. And there's authentication to worry about, but again, like, I refer you to the document for the details. And then Bob sees the connection request, which contains the connection key. Thus, Bob gets the connection key, and Bob can then accept the request, and in turn, by accepting the request, send his connection key to Alice. That was the rough idea. Yeah.
Okay, so now the trust, instead of being placed in, say, one of the hubs, or the room's host hub, is placed in whatever the discovery system is. And then it's kind of trust on first use for the connection key from, like, the first time that Alice sees Bob, unless they have worked out some out-of-bands means of, like, scanning QR codes or something in order to exchange connection keys.
Right. It should be, like, as I recall in the document, the connection key or the public key should be authenticated by the credential of Bob. So you don't just take a public key from Bob's provider. It's at least signed by a credential that says, hey, this is Bob. But of course, the credential is issued by Bob's provider in all likelihood. Again, like, how the authentication and the authentication service in Mimi looks like is still a bit up in the air. So this is also a question of what that's going to look like and how it interacts with the connection flow. Yeah, it's a bit up in the air, but there needs to be some sort of connection flow to exchange these keys.
Okay, that makes sense. Thank you.
Thanks. So yeah, that was the few more technical details on what we envisioned in terms of how, on a technical level, the pseudonymity works. I guess right now it's all in a separate document. We're looking forward to any, like, feedback on the details that you might have. If there are any questions now, I'm happy to answer. Also, of course, on the list. And then we'll see how, if or how this eventually finds its way into the main document. Because if I recall, that there was a definite interest in having such a scheme with lower metadata, and then we now just have to work out if we're going into the right direction with this, and where this should go in the main document. Okay, and that was it, and I'm handing it back to Rohan, I think, according to the agenda.
Yep, that's correct. Thanks, Conrad. Rowan, whenever you're ready.
Okay, so I did this PR, a pretty big PR on abuse reporting, which includes this concept of franking. If you go to the next slide. I tried to categorize some of these requirements for our abuse reporting. The most important here are that the hub doesn't get to see the contents of the message unless they're reported. The receiver can't lie about, they can't, claim that a message was sent by a sender that didn't actually send it, and the sender can't deny a message that they sent. Follower servers can't learn the content or sender of any message, or shouldn't be allowed to. And and then finally, we don't need either clients, either reporters or hubs to maintain indefinite copies of ciphertext over time. So moving on to the next slide. Okay, so the mechanism described here, this hasn't changed from the last time we talked about this, but if we go to the next slide, there's a little diagram here. So this is basically based on a description of the Facebook scheme. This just describes what's different. Now, I'm just going to point out that there's this between Facebook and Bob in this little ladder diagram, there's a thing that says MD, that's the context. So in Facebook scheme, that's the sender ID, the receiver ID, and the timestamp. In our case, this is the room ID, the recipient's, the room ID is the recipient. So that would be like Alice, and then the room URI, and then the timestamp. And so this last line before that little diagram, the server sends the hash of MD since Alice is not visible to the receiver. Okay, so let's go to the next slide. Okay, next slide, last slide here. Okay, so the problem with sending the hash of this context is that the follower server can brute force guess the sender of the original message because they have all the other information needed to do that. So what we really need is, if we had a key that was shared between members of the group and the hub, then we could use this in order to hash the context in a way that members could verify the context, the hub could verify the context, but that follower servers would not be able to. So we'd like, I think that there's some interest in being able to try to find a way, a standardized mechanism to do this in MLS. But I think we're going to be blocked on this issue until we have such a thing. So I just wanted to raise that, and hopefully we'll have some discussions before IETF about exactly this topic, and hopefully have a proposal for the next for the IETF meeting in Dublin. Go ahead, Tim.
I was just curious what you mean by semi-standard.
So we don't need a thing that says this is how you do. So Mimi doesn't require a dedicated for Mimi or for franking key that's shared between members in the hub. So if there was sort of, here is a generic key that can be shared between members of the hub and members between members and the hub, and it has this context or label system that you can use to hash or encrypt with it safely. That would be an ideal solution. It doesn't need to be special purpose for Mimi, but we do need some kind of a mechanism, and so that's what I meant. Melissa.
How does the notion of the hub translate into MLS?
So it would be just like semi-private message, in that it would be a particular external receiver or a list of external receivers plus the members of the group.
Okay.
For example, one way you could do this would be to send a semi-private message that distributes the key to the followers, to the clients and the hub.
Yeah.
Okay.
Obviously, we don't want to do this every message because we need to use something that, but we could do this on a per epic on a
Yeah,
perfect.
that was
That's
that
the
that
main.
was deliberately a cooked up example to illustrate the connection between the two ideas.
Okay.
All right. Okay, so that's a preview of coming attractions. I think other than that, I think I've made changes for all of the other comments that I've received on this mechanism, and it's had some review now from two people who've done some papers on franking, Paul Grubbs and John Milliken. So I think what if we solve this? If we've come up with an acceptable way to solve this problem, I think that this PR will be basically ready to merge, assuming that we agree on the requirements. That's it for me.
Okay, thanks, Rowan. All right. So I think we have 9 minutes left on our abbreviated 1-hour session. We're done with all the agenda items for today. So I guess the floor is open if anybody wants to raise another question about something we discussed earlier or something else you want to bring up. If not, we can, I think we can adjourn 8 minutes early.
So Timo just sent a message. Many discussions about recovering a room when the hub server breaks. Do you want to elaborate there, Timo? Are you talking about like a high availability within the hub? Yeah. Okay. Can followers fall back to full mesh? No. I mean, I think there's an assumption that messaging providers, that an individual instance of a server at the hub would have support for high availability and would be able to resume sending messages, would be able to resume taking requests, and that would work as it does, today on any number of commercial messaging services.
I guess also just to briefly expand on the, I guess like full mesh and some of the assumptions we've made. We early on had the brief idea of possibly being able to move the hub server to another server within the room, but we largely just deferred that in favor of making a protocol that works.
Okay, so I think that's it for today. We have another interim scheduled for October 16th. If anybody would like some, I believe Alyssa's going to be out that one, so I'll be running it alone. If anybody has anything they'd like to discuss at that time, please just let us know, mimi-chairs@ietf.org. We'd be happy to reserve some agenda time for you. Otherwise, everybody have fun on the list. Raphael, go ahead.
One last thing, we did discuss the early attachments draft in one of the previous interims. So if anybody has any feedback or any comments, happy to take them. And then we should rediscuss that in one of the upcoming interims, see how we can move forward.
Yeah, that's a great idea. So I guess I would urge you to just maybe post to the list today, pointing people at the document. And then, yeah, if you'd like, we can take some time on October 16th to discuss anything that comes up in between now and then.
Yeah, we did post to the list, I think, a few days ago with a link to the document. I can do that again if necessary.
All right, I think that's it for today then. Thanks everybody, and we'll see you in 2
Ciao,
weeks.
everybody. Thanks.